So myself, I'm Dominic. I'm delighted to be your host today for this important session. As someone, spent over 3 decades in the field of fire and investigate fire accident and about life safely. I strongly believe that promoting awareness and adherence to global safety standard is not just important, but it is today essential. With rapid rise in solar energy adoption, ensuring that installations are properly verified and compliant with international standard has become more critical steps in achieving long-term safety, performance, and reliability. That's exactly what we are focusing today. We are very fortunate to have Mr. Shyam Ravindran, an experienced technical expert in electrical testing and measurement. He will walk us through the key aspects of IEC 62446 and IEC 60364, sharing his practical insights on how these standards guide the safe and effective commissioning of solar PV systems. I encourage all of you, all my friends who have joined. We have over 800 registration today, which shows the interest in solar PV installation. So stay engaged, take notes, note down your questions. Feel free to drop your question in the Q&A box. Down when you see there are menu in that Q&A box. Put your Q&A. Sham will take up these questions, and we hope we'll find good time for interaction with your question and answer. So myself, as I've already explained to you, founder of um, FSA, Fire and Securitization of India. I'm a founder of Focus, which is Forum of Construction. Today we have changed the name to Forum Construction Utility Services, and also founder member of NFE, National Federation of Engineer for Electrical Safety. And I continue to associate with electrical professionals and to try and understand why we have been having this short circuit cause for the fire is electrical. So, and with me, my friend, handsome man, Shyam Ravindran, who's been traveling again length and breadth along with us. And I'm so happy to introduce Shyam, who holds master degree in electrical and electronic engineering from WT Poland. With over 15 years of leadership in solar India, Shyam has played a pivotal role in shaping the company's growth across Indian subcontinent and emerging market. Under his direction, Sonal has grown from promising entrant into a trusted name in electrical testing and measurement, specializing in power quality and electrical safety solutions. He brings deep expertise in market expansion, strategic innovations, and building long-term partnership. Sham is known for his hands-on leadership in driving Sonal's India's operation and increasing its footprints across the Indian subcontinent and Middle East and emerging economies. At the heart of his work is a passion for empowering teams, driving sustainable innovations, and delivering reliable, standard compliant solution for safer electrical ecosystem. That's Sham for you, ladies and gentlemen. I now welcome Sham to take over from here. We will have 45 minutes and we do 30 minutes of question answer. Sham, over to you.
Thank you, Mr. Dominic, for this introduction. Before I begin, I just wanted to quickly, though Mr. Dominic has introduced himself, but I just wanted to quickly, share the thoughts of our association. We started our relationship as, associating for the promotion of electrical safety. And as Mr. Dominic has mentioned, we have been running length and breadth across the country to promote the electrical standards across. And I really enjoyed the time that I worked with Mr. Dominic because He's passionate enough in, though, as he mentioned, from not from an electrical background, but the fire related to electrical safety has been, joined hands over the years. And frankly, I learned a lot during this years of associating with of associating with all these associations, and also with running through their leadership people like Mr. Dominic. So thank you, Mr. Dominic, for this journey altogether. And in terms of the meeting today, to be frank, we try to reach out to our customers that this is the plan what we have. We are going to make a presentation on IEC 60364 and 62446. And we contacted some of the solar plants, I think a month before when Mr. Dominic proposed this idea. Actually, there was didn't start well though. It was like, no, the monsoon season have started. Maybe it is not the good time to discuss about this particular topic. But we are actually amazed to see such a volume of registrations. About 700, 750 plus registrations are being done, and over 100 participants. So I humbly thank you for all your interest, and I believe I'll try to make some justice for the interest that is shown out. And also a big, congratulations to Mr. Dominic and his team to do this marketing in such a short period of time and bringing audiences not only from India but also from the overseas markets. And also a good shout out to our team. I'm just making a presentation here. There are a lot of people who are involved in this activity, starting from product development, presentations, verification. So there is a lot of guys behind this webinar from my team as well as and from my team as from India as well as from also from Europe. So a big thank you for all my team members as well. So let me begin the session as verification of photovoltaic installations as per the IEC 60364. This is a very important topic today because we are all running towards a sustainable development and the ability to do it over a period of time. And we have seen not only the companies, we have seen the governments behind this, I will say, a mission. And the right philosophy behind this will be how the entire, we can even call this as an era where there is a change on sustainable development. So that's how this solar, electrical vehicles, all these renewable energies, the power related to anything related to it, we are all behind the sustainable development. So that is something which is very fascinating. And I'm lucky to be, a part of this kind of a sustainable developments. And if we look into it quickly from Indian context, this is our, I think, the third webinar which we are doing. And I kept all the first three points from my previous presentations. But if we look into it from the last presentation to now, where when we started, it was what, when fifth largest PV deployment across the globe. Now we are the third largest PV deployment across the globe in just a span of 3 years. So there is a mission behind this activity. The total RE capacity reached 220 gigawatt as per the recent article. I can actually proudly say this is our effort in the fight against the climate change. So this is something which is significant. So not only the companies are behind it, the entire government is behind it for such kind of an activity. When I move from India to, for example, UAE, I was lucky enough to be in this farm, in the solar farm in UAE, Mohammed bin Rashid Al Maktoum Solar Park. I can literally tell you, I was driving from one gate to another gate by 24 minutes, a good 20 minutes. Such a large installations, and the plan, the mission by all these governments are absolutely fascinating. So the technical part of my presentation will be to give you a complete glimpse of the verifications on the DC part, AC part, Up to it is connecting to the grid. Yeah, so we will have a look. Currently, the most of the solar farms are at 1,500 volts, so the DC can be at 1,500. Let's stick to 1,500. If it is less than 1,500, it is completely fine for our verification. So the maximum what we see across India currently is about 1,500 volts on the DC part, and on the AC part, it could go up to 800, and then when it is stepped up to the grid, it could be a 33 kV, for example. So we will verify the installations up to it reaching the grid. This is the overall context of 60364 and 62446. As we very well know, 60364 talks about 1000 volt AC and 1500 volt DC. To all the Indian audiences, because we also have some international audiences in this event, so let me give you a quick overview of the Indian standards and the title of the Indian standards. 60364 will be referred or could be referred from NEC 732, 3043 and 18732. And 62446, the equivalent standard could be 16960. I will also talk briefly about the last of the session when the couple of slides will be about power quality and the importance of power quality in grid connected solar farms. I will also share some the guidelines that is given by the distribution companies in India. That will be the last of my presentations. So before we begin diving deep after the standards, there are 3 points actually I always mention in my presentations. There is 3 points that is absolutely important for us to do a verification. One, what standards? So that's the title of the presentation. That is the standard that I'm going to make a measurement about. The second will be the standard of the equipments. So whatever will be the tool, whatever will be the manufacturer, you are supposed to understand the standard of these equipments before you start the measurements. 61557, which will play a very critical role, and the related to the category of protection, that is absolutely important. We have four categories four categories of separations on the electrical assets, where it's Cat 1, Cat 2, Cat 3, and Cat 4. Cat 1, which is not directly connected to the power supply, for example, could be a laptop, and Cat 2, Cat 3, and Cat 4 up to the main distribution boxes, as you see on the pictures. Now, why this is important? Because when you make a verification of an electrical installation, one, you have to understand where are you going to make measurements. So that is the tool that you're going to make the measurements safe enough for you to start the measurements. So please be very cautious in looking out the standards, what the tool that is being used for such kind of measurements. And that is only a half of the story, because when you make a measurement, if you find any impulse voltage, there shall be a necessary protection for it, for you, and also for the devices that you use. So there is a lot of informations behind it. Last but not the least, when you make a measurement on a Cat 3 or a Cat 4 on the same rating, let me give you a quick example. If you make an insulation resistance on a Cat 2 and a Cat 4 is completely different, you will be choosing a different voltage, you will be expecting a different resistance value. So in totality, the summary of someone who will start a measurement, I personally think there is three things that is very important. Please refer to the standards. Please refer to the standard of your equipments, and please be cautious where are you making a measurement so that you can interpret the results. Now, I mentioned a good positive note when I start the presentations. So let me give you a finance behind it. In fact, in the last webinar, someone did ask what is the cost of 1 megawatt plant. This is varying completely between the state, in the state which you're operating in, the benefits that is given by the state government, central government. In the other countries also, this is slightly different. 4.5 crores, approximately $500,000 is approximately required for you to start 1 megawatt plant. And you're expecting to have a generation of about 1.4 million units, let's say. And this rate is also completely could change between 4, 5, 6, depends on the state which you're operating in. And you could actually expect a revenue of about 56 lakhs, about 5.6 million Indian rupees. Yeah. And you are expecting to have a return of investment on 8 years, and you have a remaining 17 years, let's say 20, 25 years is the operation of the plant. That is the ideal expectation before we start a solar plant installations. The big question is, if you do not do the verification, are you sure this is going to be there for the next 20 to 25 years? Are you sure? Because when I tried to, before this presentations, of course, I tried to visit a couple of solar farms in discussing with the customers so that I can collect their pain points and share it in this common forum. I was literally amazed. I can say at least, I'm not talking about the really large solar farms. I'm talking about small packets of solar farms. Someone who is starting 5 megawatt or a 10 megawatt solar farms. It's literally about counting the number of units that is being produced. I was really shocked that the verification of these plans never happened, and I am confident with what I'm saying right now. It never happened for such small farms. Being an electrical engineer or who works on the safety part, we become a little bit paranoid when we hear such kind of statements from the customers. I'm a kind of a guy, after all this, working behind electrical safety. I have even, I mentioned in the past also in many webinars, there was an electrical fire accidents in the apartments where I stay in. So we are no one is spared from this electrical accidents. And when we talk about DC farms, DC areas, and if the electrical verification is not happening, considering the farms, rooftop installations, whatever it is, as a testing engineer, or when you look into it from the safety point of view, this looks little bit scary. And also to the guys who are making these investments, please be cautious. You have to ensure this is operational for 25 years, means there shall be some level of verification or some level of audit that must be done. There is an equation on finance, and that's why I wanted to show this finance. Let me give you some of the pictures. As a company, we work on various, industries and industrial types. I've never seen aluminum bus bar burn. I mean, I've seen burning in an electrical installation, but I've never seen an aluminum bus bar melting other than a solar farm. This shows this is quite dangerous if we are not putting the enough cautions. And I'm not even sure what is the level of training that is given for the engineers in small farms to do such kind of maintenance on a routine way. Lot of explanations are given behind poor workmanships, or a lot of factors are behind such kind of an incidents. But I have never seen an aluminum bus bar melting down other than a solar farm. Personally, I've not seen. I've seen fire accidents, but I've never seen such level of unsafe condition other than a solar farm. So I think this is very very important for us to understand. If we are keen on, taking back our finances and also ensuring a safe working environment, verification of an installation becomes inevitable. Moving forward, I do not want to give any of my theories in my presentation. I only wanted to share what is written on the standards. We come from an industry where we manufacture some tools, and our job is just to prepare the tool as much as we could to match the standard requirements. So there will not be any suggestions personally from me or from our company. This is going to be purely discussed on how we do the verifications on the installations, exactly what is written on the standards. So most of my slides are going to be a copy paste from the standard. So I do not want to give any kind of personal suggestions in how you build this verification. So let's start from the AC part and we'll move to the DC part. Before we do that, a very important and most recommended or the ideal place is you have to know some kind of a visual inspection, which I have noticed in almost all the small and the large farms. There is a lot of ideas that is having by the maintenance managers. They're able to inspect it. They're able to tell what is going on. So this visual inspection plays a very very critical role. Though we have the necessary testing tools behind it, this is going to be the primary part for us to start the measurements. Now, first, when we talk about 60364, we are talking about all the 10 testings. which we have been discussing with all the NFE events over the past 2 years across India. So this 10 testings will be applicable for the solar verifications as well. So we are now talking about, before we get into the testing, as you can see from what I've highlighted in the yellow, the equipment shall be complied to 61557. I will show you some slides in terms of the measurement accuracy. If it is not a 61557, I will give you such kind of an idea, and we will also talk about in detail about the category of protection if time permits. Now there are 10 testings. As you see from the slides, I've marked something in green and something in red. So this is when you will make a measurement as whether in the switched on condition or a switched off condition. Let's get into the details of each and every testings in the next slide. So it must be in the order of sequence of the 10 testings. So let me read the last sentence. It is also quite important. In the event of any test indicating a failure to comply, the test and the preceding test, the result of which may have been influenced by the fault indicated, shall be repeated after the fault is rectified. Which means if you straight away get into some tests, it's not according to the standard. You have to follow the sequential procedures. And if any one of the tests that is failed, you have to rectify the fault and repeat the measurements. That is how a verification of an electrical installation should happen. The first part is the continuity. It's quite important to understand if there is a continuity, but this is a very simple test, yeah. But this is the first test for us to understand the continuity of conductors and the exposed conductive paths, if any, shall be verified by the measurements of resistance on. We'll be making it on protective conductors, including protective bonding and exposed conductive path. So this is the primary test we establish to understand if there is an electrical continuity. Uh, it can be done using a very simple tools also, but the first test is to understand if there is an electrical continuity. The second part is insulation resistance. Please note there is insulation resistance on AC side and DC side is slightly different, but this is on the AC side. But the tabular column, what you see on the screen, that the ohmic value remains almost similar for the AC and the DC part. So the insulation resistance, though it is a very common test used by the engineers, we have to understand the what is the nominal test voltage that you are supposed to apply and the ohmic value, that is what is the appropriate ohmic value for us to put into the report. Yeah. So this insulation resistance shall be made between live conductors and the protective conductors, and when appropriate, the live conductors may be connected together to start the measurements. Some more additional information regarding this insulation resistance is this is quite interesting. But this is exactly all, as I mentioned, this is all written in the standard. Yeah. So where you have an SPD or equipment that is likely to influence the verification of this insulation test or be damaged, such equipment shall be disconnected before carrying out the insulation resistance. And if you think it is not possible to remove, you could apply, for example, a 250 volt, but the ohmic value what you should be expecting is 1 mega ohm. In a TNC system, measurement should be made between a live conductor and a PN conductor, and the insulation resistance values are much higher than that of table 6.1. This is the table, sorry, I didn't put the title of the table. This is table 6.1. It will be much higher. You are going to expect even much more higher values while you make a measurements, but the minimum requirement by the standard is 1 mega ohm. Then comes out the insulation resistance or the impedance of flows and volts. I can confidently tell at least 95 or more than 95% of the installations do not make this measurements at all. It is the same insulation resistance. Before I read the standard out for you, let me show you what does it mean by floor and volt resistance. You see on the first picture that is an extraneous conductor. Approximately 1 meter above, we apply uh, 250 newtons of power using some special tripods as mentioned in the standard, and we measure what is the ohmic value. This is also applicable in the floor where you have all your insulating mats. Let me write out the standard for you now. When it is necessary to comply with the requirements of 60364, Clause C1, at least 3 measurements shall be made in the same location, one of these measurements being approximately 1 meter away from accessible extraneous conductive part. So What is accessible? It is accessible to me. I can reach out to that device or the conductive part, but it is extraneous, so it is not a current carrying conductor. So it is an accessible extraneous current carrying conductor, and two measurements shall be made and slightly above more than the distance, and I measure what is the insulation resistance. It is the same. You will be applying a known DC voltage, but you wanted to understand if there is any floor and wall, insulation damages or in your measurements. So this is very important in our panel rooms. Then next comes about the polarity. Polarity also, it's a quite simple test. Yeah, we understand what is the polarity. This is very important, shall be verified before the installation is energized. Maybe not quite extensively used after the installation is energized, but before the installation is energized, it is absolutely important to have it to measure about the polarity. Then the most important part, it is protection by automatic disconnection of supply. This is important for us to understand how the protection of automatic disconnection of supply works, which is none other than the measurement of fault loop impedance measurements. So the measurement of fault loop impedance is very important for us to understand how do I get the automatic disconnection of supply. In a short summary, as an electrical engineer, how do I want it always summarize as if I have my electrical installation, if there is an electrical short or there can be a failure, I expect my protective devices, whatever will be in your installation, shall trip. And there is also a very clear indication what is the voltage value you're operating, what is the type of protective device that you're having, and what is the maximum time duration that it must trip is also clearly mentioned in the standard. Then, if it is getting tripped, I do not come to the first point on why is there a fire accident. Because if it is tripping, we should not be expecting any electrical failures. I mean, electrical fire accidents, for example. Now, looking into the characteristics, we have three different characteristics, B, C, and D in our most of our installations, and the multiplication factor of each and every breakers are shown as you can see here. For example, let me give you an example of a B-type breaker. First, the first part, an example of B16. Let's analyze this B16 as a breaker. Let's say the equipment gives you ohmic value of 2.041 ohm after you make a measurements. Most of the customers, whether wherever they make a measurements, they ask, is it okay or it is not okay? Sham, I have 1 ohm, is it okay? I have 2 ohm, is it okay? This is how usually the customers do ask us the question, is this okay or not okay? So let's narrow down the total requirements. Imagine this is a 230 volt. And as per the standard, the response time for this installation is 0.4 seconds. I'll show you the tabular column later on. So for a B16, the B having a multiplication factor of 5, as shown in the graph before, you are expecting a triggering current characteristics of 80 amps. So if you have an 80 amps on a 230 volt, please look into the equation on the right hand side. 230 volt divided by 80 amps, you should be expecting an ohmic value of 2.875 ohm. But what you are getting as an ohmic value for example, a measurement. This is an example. If example, your equipment gives you 2.041 ohm, but actually what are you supposed to get? You're supposed to have the equation is 230 by 80, that is 2.875, but this is lesser than this, so this is completely okay. Why it is completely okay? If you will divide 230 divided by 2.41 ohm, this is 112.72, so this is perfectly okay for our installation. Yeah. Now, the same characteristics what I showed you here, I have given in the formula representations as well. Now, if there are, this is important for us to understand in what type of system am I making a measurement? Is it a TNS system? If it is a TNS system, how does the coordination work? As we clearly see from this picture, this will be the path of a prospective fault current. So this is I will say, the most ideal system, the perfect system for any coordination to happen, which will be definitely a TNS system. But if you take for a TT system, which is quite common in most of the installations, is the return path is not through the metallic conductor because your neutral and PE are combined, and you have a return path, for example, is established as a return path through the ground. So here, whatever will be the ohmic value compared to a TNS system will be definitely higher in a TT system because we don't have a direct connections. So this is the most opted method considering the cost, but we can be sure that the follow-up impedance value is not going to be falling in most of the installations or calculation as per the prescribed limits. This is quite interesting for the Indian audiences, what is written in the National Electrical Code. So what is the basic purpose of earth fault protection? What is really the basic purpose? There are two instances. Firstly, the voltage is appearing between the exposed conductive part and an extraneous conductive part. And if these parts are simultaneously accessible, the voltages constitute a shock hazard. This is your indirect contact. Secondly, this is very, very important. The fault current that flows in phase and the protective conductors of the circuit feeding a faulty equipment may be of such a magnitude as to cause an excessive temperature rise in these conductors, thereby creating a fire hazard. Now, if you read into it very carefully, it shows the fault current, yeah, that is feeding the faulty equipment, that is creating an excessive temperature. But as I showed you in the fault of impedance measurement and calculation, if we are actually having a proper disconnection in that particular time, first of all, it should not continue to feed the faulty equipment, and there is no way that the temperature also should be rising. So that the tripping not happening on that particular time is the major reason of a fire hazard. And in totality, there is two summary, yeah? Overrated breakers and an underrated cables. This will be the two common culprits in our scenario. If you have, for example, a overrated breaker, this is never going to trip. If it is never going to trip, what is the purpose of having the breaker in the first place, which is definitely going to create a fire hazard? So measurement of fault loop impedance is going to be an inevitable factor for us to ensure there is no fire hazard in this in our installation. The choice of protected device and the disconnection is influenced by the type of system and the installation of which it is a part of. For example, there are different type of breakers, there are different type of systems. So the consultants, contractors, designers who will be making this kind of an installation or the design as per the location, because what is applicable for a solar farm is definitely not applicable, for example, if you construct a swimming pool or a residential apartment. So for every location, there is a requirement of a different protective devices. But we can actually, I'll show you in the next slides, we have to summarily cut it down to what is a type of a system and what is a type of a breaker. And based on that, we will be in a position to understand by making a follow-up impedance method, is it safe of our installation. So for this different type of breakers, you will be able to find this calculation in the IEC standards, as well as this is a screenshot I've taken from NEC National Electrical Code, but this is the same. Yeah. So for the thermal protection, for example, for a B16 breaker, for that thermal protection, the two-third of the value is only allowed. So for example, two-third of the voltage by current is 1.92. So for every rated breakers, what is the allowed impedance value is given in the calculation or in the tabular column. So all this summarily will be communicating to the final points. The automatic disconnection of power supply to the circuit equipment in which the fault has occurred within the restricting time, and limiting the prospective touch potential between exposed conductive part and any other extraneous conductive part. This safety measure is protective equipotential bonding and automatic disconnection of supply. So all we are trying to understand is, do we have a protective equipotential bonding and the automatic disconnection of supply? The protected device shall be taking into account the characteristics of fault current and fault loop impedance of that particular circuit equipment and sections. If you look closely into it, if you are closer to the transformer, naturally you will be expecting a much lower impedance value than you are far away from the transformer. But as I told you in the beginning of the presentation, the closer to the transformer, what we mean is you are not in the CAT 2 area, probably you're in the CAT 3 or a CAT 4 area. So here you should be expecting a higher voltage. Because it is a higher voltage and it is a low resistance here, the order of a prospective short circuit current is also quite significantly higher. So this requires special equipments and special protective methodologies for you to make this operations. If you, let's say, you are far away from the transformer, let's give an example. For example, inside a building where I'm, for example, in where I'm making this measure, this presentation. If I make a measurement in this particular room, we should be expecting much higher value compared to what I will be expecting when I am closer to the transformers. This is something which is very important because we have to make this follow-up impedance method or measurements starting from the smaller or the sequential way, and we will reach up to the source end. So when you reach it to the source end, as per the diagram you can see, you are expecting a 800 volt before it is connected to the grid, and the grid can be anything. For example, 11, 22, 33, whatever. Yeah, you are connecting it to the grid. But in the AC part, you are expecting about 800 to 900 volt. Making a follow-up measurement, follow-up impedance from a 230, 400, and then when you reach an 800 volts, you will be expecting a very significantly high fault current. So this is something which is very important, but you are establishing a complete sequence that starting from my socket area up to my source end. I'm clearly sure wherever there will be a fault, we have a proper installation that is safe enough and that will trip in any part of the circuit. We only draw a line, yeah, from the AC part. We only draw a line, and then we are putting some protected devices near the source end. But if you look into it, there are a lot of components in this line. What I mean by a lot of components is there could be a lot of loads or circuits or anything that is connected in between of this line, and you have to ensure that you are reaching up to the final end of this verification. So for each and every installation, not only that I have given you the ratings, this is the disconnection time that is very, very important. So for example, if I have a TN system and if I have a 230 volt, I expect on a disconnection time is 0.2 seconds. So from the other presentation which I showed it to you, if we were showing that the faulty equipment has been feeded with, I mean, the faulty current has been continuously feeding. No, it cannot happen. You have to make a disconnection within 0.2 seconds or whatever will be the rated voltage and the appropriate AC or a DC connection you have. Within this particular time frame, it must disconnect. So let's take a quick summary. It should disconnect appropriately on this particular time, but generally for us to understand, within a second it should disconnect. Yeah, but we have to follow that nomination very clearly. It's 0.2, it's 0.2, but at least within a second we have to be sure that it is disconnecting. But what is actually happening now is it's not actually disconnecting at all. It is continuing to feed the load for days. The temperature keeps increasing, and then finally we have a fire accident. Lastly, about the measurement of resistance of earth electrode, which is your earth pit resistance method, 6.4.3.7.2, which talks about the appropriate earth resistance measurements. As far as I know, we do earth resistance measurements in the solar farm and we do thermography. These are the two tests that is being done, but let me show you what is written as for earth resistance. But before we get into earth resistance, let me give you a quick snaps of earth resistance. There is earth resistance, soil resistivity, and the measurement of earth resistance for your lightning protection coordination. These are three different discussions. First is earth resistance. Second is soil resistivity, which you would have made a measurement before you start the installation, before you even created your installation. So that is completely separate. I've noticed some of the discussions in the past, people were trying to combine the soil resistivity with the four-pole terminal method. Soil resistivity is different, earth resistance is different. Now, when you make an earth resistance, we are now making an earth resistance to understand what is the purpose of our earth resistance. Let me read it out for you. The measurement of earth resistance of an earth electrode where prescribed shall be made by an appropriate method. So the methods you will be able to find in the Indian standard 3043. Uh, but the measurement of earth resistance is slightly different from your earth resistance on an LPS inspection, which is your lightning protection inspection report. In a LPS inspection report, you will be using a high frequency or a impulse method. This gives you an idea. If I have an earth pitch, I have to be sure how does it really work in terms of lightning protection. Yeah, so I actually, as you see in the National Electrical Code page number 248, let me read out the note. High frequency or impulse methods are possible and useful to determine high frequency or impulse behavior of the earth termination system. Such measurements may be performed at this stage of installation of earthing system to check the adequacy between the need and the designing earth systems. At least once in, I will say, a couple of years, you will have to do your LPS inspection report as prescribed by the state authorities for LPS inspection. Regularly, what is an earth resistance is you disconnect the earth pit and you make an earth pit resistance of that single earth pit. This is our four-pole traditional fall-off potential method where I am able to measure the individual pit resistance by disconnecting. But 3043 section 41 talks about, also the IEC standards talks about measurement of individual pit resistance by using special CTs. So there is practically no need for you to disconnect the earth pit. You will be able to make the individual pit resistance measurements. So what is this impulse method is in the shape of the impulse you will find it in the standard. It's not mentioned in the previous slides. The standard number is 62305, which is approximately the shape of the pulse, which talks about the rise time. I mean, from the 10% rise time to the 90% of the rise time, which is your time one, and from the 10% of the rise to the 50% of the decay, which is your time two. Totally, the duration of the pulse shall be, as you see in the small screen, 4 microseconds, 10 microseconds, 8 microseconds, 20 microseconds, which means the total time duration of this measurements will be about 10 or 20 microseconds. As mentioned in National Electrical Code, either you can choose an impulse method or a high frequency. So the right terminology is earth resistance, earth impedance, soil resistivity. These are three different testings. Then the additional protection is the additional protection of the effectiveness of measures applies. For additional protection is fulfilled by visual inspection, and where it is not possible for us to establish, we have an RCD required for an additional protection. Then it is also about the phase sequence. Phase sequence, though it is usually verified and the mostly in the beginning of installation, it is also appropriate whenever we make any kind of changes. We need to understand if the phase sequence are proper. So for RCD, generally when we do RCD, we have to be sure about the choice of RCD very clearly, like what I mentioned for the type of the breakers. B, C, D type of breakers. There are also type of RCDs. You have to choose the right type of RCD, right ratings of the RCD. If you do not, if the coordination is not proper, again, it is also not going to trip. We can make a measurement whether, for example, let's say I make a measurements on an AC type RCD, for example, but you're using it in a solar farm. There is no point at all because we have to be using the right type of RCDs in that particular installation, and the right rated of the RCDs is also very critical. Then we go and make a measurements. Okay, I have this type of RCD in this particular rating. Then the testing is appropriate. So I'm not commenting on the design, but if the design is wrong, the testings could sometimes help you in understanding, okay, this is wrong, but in some of the instances it becomes important for the engineers to understand. It is also important to choose and also to verify. So when you make an RCD for an additional protection, we will be making a measurements on the nominal value, 2 times the nominal value, and also for the 5 times of the nominal value on the positive as well as the negative. So we will make a measurement on the current value and what value the RCDs are going to trip and what value, I mean, what is the time duration on the RCD measurements. But as I told you, so I will be making a measurements on this, but If there's a right, I mean, if it's a wrong type of RCD that is being chosen, probably it might not be clear only with this verification. So please be cautious here on the type of RCDs. And in the beginning, I have mentioned about 61557. So I come from a manufacturing company who manufactures the testing equipments for the 61555s. I mean, complying to all these IEC standards. At least that's just what we try to do. We try to comply and make measurements for, I mean, make equipments for complying to these standards. So in our data sheets or in any manufacturer's data sheets, you will find accuracy of the equipment is 2% or 1%, and we are happy to say that I got an equipment for 1%. But let me give you some of our opinions about this from our point of view, from the equipment point of view. The measured value of an insulation resistance has a permissible measurement error of 30%. Short circuit impedance 30%, earth resistance 30%, RCD touch voltage is 20%, and tripping current is 10%. Now, let me show you what does it mean by that. This is, though I have not given it in an animation way, let me show the screens very quickly. Example, a meter with a resolution of 0.01, and the basic error is plus or minus 2% measured value plus 4 digits. What actually we do is we see this is the basic error plus or minus 2%. And we think, okay, this equipment is plus or minus 2% only. But after the 2%, there is plus 4 digits. So let me give you an example. If you are making a measurement on 1 ohm, 2% of that 1 ohm is 0.02. The error digits is going to be adding here, so it is 0.04 because the basic resolution of the equipment is 0.01. So your error digits are just going to be added. Now you have a total error of 0.06 ohm. So now the measurement error is 6%. If you make a measurement of 0.13, this is very critical. If you make a measurement of 0.13, 2% is beyond that 2 digits. So I'm giving 0.00. And the 4 digits remains the same because that is where that is as per the digits. Now the permissible measurement error is 30%. So we have to be very cautious when we are making a small resistance measurements, generally anything which is small value, because let's say I will give you an example of an insulation resistance. Insulation resistance, when you make a measurement, when you buy a tool, whether it is 1 ohm, though you have to comply 61557. I mean, please don't take my interpretation in a wrong way. I'm just giving you an idea. If you have a measurement of 5 ohm or sorry, 5 mega ohm or a 6 mega ohm, how does it matter? If you make a mega measurement and you get 100 giga ohm, how does it matter? So, but when you make a measurement on a small ohmic value, it is very important for us to understand the not only the accuracy but also the digits after that, so that I can clearly understand. Okay, is it falling within the standards? If we are not, I mean, willing to learn everything about the equipment and the nuances of the equipments, at least check if the equipment complies to 61557 in the type test reports. That will give everything that is related to the measurements. Now let me move into the DC part. Sorry, we are running out of time. Let me try to squeeze the presentation slightly quicker so that we can finish on time and take the appropriate questions. So for the DC part of measurements, the stable conditions, the optimal expectation is 400 watts per meter square. For IV curve, generally we expect a good IV curve. Good IV curve is to really understand if the power production is appropriate as 700 watts per meter square. So according to 6466-1, the minimum versions of the documentation should contain the information about the system, designer, installer, system descriptions. So let's say every documentation before I start the measurements shall be available. Then I get into the measurements. So what are the measurements that I'm going to make in, so in 60364 it is 10 tests. In 62446-1, there are 2 categories and an additional test. So category 1, which talks about continuity, polarity, combiner box, open circuit, short circuit, functional, and the insulation resistance. As I told you, there is a slight difference between the insulation resistance on the AC side measurements and the DC side measurements, but the theory remains the same. Then we get into the category 2, that is IV curve and thermography. If you do the IV curve, because I see mostly people the straight away do the IV curve measurement, which is okay. But let me read out also what is written in the standard. If you do IV curve, you don't have to do test number 4 and test number 5, but the sequence. What I mean by sequence is, first let's do the continuity, polarity, then you will be able to start the measurement on IV curve. That's how the sequence is. It is also mentioned in the standards. So let's get into each and every testings clearly. I've also shown the exact representations that is in the standard, as I mentioned at the beginning of the presentation. Nothing will be as a comment from my side. Since this is a verification as per the standard, my job is only to interpret exactly what is written in the standard. So this is continuity of protective earthing and equipotential bonding, where protective device very similar. Yeah, well, like in the AC part, we are also doing the measurements on the DC side. We are measuring if there is a continuity of the measurements. Then we get into the polarity. So for the polarity, uh, we are ensuring, though this polarity test is could be identified or could be interpreted in the sequential test. Polarity test is very important when you first energize the system, so that you are truly able to understand positive is truly positive and negative is truly negative. So once when polarity is confirmed, cable shall be checked to ensure that they are correctly identified, correctly connected, and system devices such as the switching devices of the inverters. So then is open circuit voltage. But again, as I mentioned, if you once when you finish this test, and if you're straight away going into the IV curve measurements, the open circuit voltage and the short circuit current methods will anyway be written over there. So it is your choice. It is also mentioned in the standards that it is up to the decision of the customers. Yeah. So now regarding the open circuit voltage, to check the modules are correctly wired, specifically that the expected number of modules are connected in series within the string. Missing an interconnection or mistakenly interconnecting a wrong number of modules within a string is relatively a common error. Basically, what we are trying to do is, I'm going to check a module with lot of strings that is connected. So if I have an open circuit voltage, and if I have 10 number of strings that is connected, I will be expecting the maximum number of the voltage by this open circuit voltage measurements, and the relative error on my theoretical representation or the measurement is, for example, within 5% is my tolerance limit. When I get into the IV curve, this is much more clearer. You will be able to see what is the maximum voltage and what is the maximum current. Let me also get into the ISC calculation. So what is an open circuit voltage is, we are able to identify what is the maximum voltage that is mentioned between the two terminals, that is positive and negative. The same applies for a short circuit current. If we are going to identify, when we get into the IV curve, it is very clear. So the short circuit test will give you the maximum current, because what I'm trying to do is I'm trying to short, and I'm having the in terms of an open circuit voltage, I have an open circuit voltage and a maximum resistance. In terms of short circuit current, I have the least amount of resistance and the highest amount of current. So the combination of this open circuit voltage and the short circuit current gives the maximum power, which will be theoretically or practically evaluated in our theoretic and practically evaluated in our IV curve measurements. So this is how we make an IV curve measurements. We are able to make a measurements and create a short, and then I'm able to calculate what is the STC condition and what is the value I'm able to make a measurements. Then when we talk about, as I mentioned to you, this is mentioned also, an IV curve test is acceptable alternative method to open circuit voltage and short circuit current as 5.3.4, where IV is performed, separate VOC and ISC are not required. Because I mentioned in the beginning of my presentation, we are supposed to go in a sequential way. So here actually I'm bypassing one sequence, so I'm just putting out one clarity for you guys. Then it is about the functional test. Functional test is purely about the functions. It's not a very thing which is not anything appropriate to make an identification. So, for example, I'll make and understand if the switch gears and all other control apparatus shall be tested to ensure correct operations. Our inverter operations are verified. So, the test procedure shall be defined by that particular inverter manufacturer. So, it's purely about the functional operation of my panels. Then this is about the PV array insulation resistance. So as I told you, this is a slightly different test compared to an AC test, because here a PV array DC circuits are live during the daylight, and unlike a conventional AC circuit, cannot be isolated. So the isolation is not proper. I mean, possible here. So that is the only difference. So what is most important here is safety. So limit the access, which means if you're going to make a measurement on an insulation testing on the DC part, please be sure that people are not, around this area. What I really mean by that is, if they touch any metallic surfaces, it could be a potentially a hazardous scenario, because it is live and you're also testing this DC insulation resistance. So the only part which we will have to be a bit careful about is when we make this measurement is how safe are we when we do this insulation resistance. But how you interpret an insulation resistance is the same. You have the resistance value that is measured, and the rated value, tested value, minimum insulation resistance almost remains the same. But for anyone to understand, please keep in mind about 1 mega ohm. That is what you should be expecting in whether you're making measurements on AC side or on the DC side. The most important part of our DC part of evaluation is our IV curve. It is very important for us to understand from the safety aspect as also from the financial aspect. Because why financial aspect? This IV curve is going to establish the maximum power. So if I have a panel which is rated for X rated power, is it truly delivering that power? But though the conditions and the STC conditions are different, but the real time when we are making a measurement could be slightly different. But we are making a power production in this particular IV curve, and we will be able to understand, is it truly generating, or it is truly producing such kind of a power. So IV string measurement or IV curve measurements, you will be able to understand the open circuit voltage, short circuit current, maximum power voltage, maximum power, maximum array performance, measurement of module, the string fill factor, which I will show you in the next slides, the identification of the model, sometimes even the array defects or shading issues. So this gives you clearly most of the agendas behind our measurements. That's the total purpose of this IV curve. The string under test should be isolated and connected to the IV curve. If the purpose of IV curve is solely to derive the values of VOC and ISC, if your agenda is only to identify, then you don't have to make a measurement on irradiance and cell temperature. So before starting a measurement on IV curve, what is very important? We need to make and understand we make a separate understanding. I mean, there will be a separate tool. We call it as an irradiance meter. And this irradiance meter will be consistently delivering the irradiance measured to the equipment which is measuring your IV curve. So please ensure there is a proper connectivity, because this irradiance value is very significant for you to identify what is going to be your IV curve measurements. Please be sure about the connections. Please be sure about the angle of inclination, rightly fitted. What the right word is, please be sure if it is rightly fitted. Small mistakes in that could sometimes be interpreted in the wrong data. So regarding the array performance, the suitable irradiance conditions and IV curve tests provides a means to measure the performance of a PV array in a meeting related to the nameplate performance. So we have a nameplate detail. I'll show you in the next slides. I've taken some of the manufacturer's nameplate detail just for us to have an idea what are we discussing about. And we are going to map that STC conditions while we make a measurements. So the PV string and an array performance measurement shall be performed at a stable irradiance conditions. As I mentioned at the beginning of the presentation, at least 400 watts. But a real I will say the right radiance will be at least a 700 watts per meter square. When you're making a measurements, if you will rush out through when there is a lot of cloud movements, if you rush out through these measurements, you will kind of conclude that the power performance is not true. But if you will correlate with the irradiance that is during that measurements, it will correlate to the measurements in many of the scenarios. So let's be very clear about having a right atmospheric conditions when we are making these measurements. The procedure for IV curve is also the same. Let me read out some quick points here. Ensure the system is shut down, completely shut down. The string under test should be completely isolated. The test instrument should be programmed with the characteristics. Here, as a company, we try to create some handy scenarios for the users. What I mean by that is we are able to feed in the data of almost most of the solar panel manufacturers in India and also globally. We have feed it in our systems. If you have any specific module, you are able to program and keep it in the memory. So when you go for a next measurement, you're able to, no, you don't have to enter it every time. Fetch out the data of that particular module from the memory of the equipments, and you're able to start the measurements pretty quickly. And you can actually compare what is the STC conditions and the result that is produced very swiftly. So this is all together about how we start the procedure on the IV curve measurements. Now, what is this IV curve? Let's put into the graphical format. Yeah. So this is nothing but a plot between the current and voltage, where we are able to have an understanding of the ISC, which is the short circuit current, the maximum short circuit current, and my open circuit voltage. So when I have a truly open circuit voltage, that is the maximum open circuit voltage that can be established. And when I short it, that is a maximum short circuit that can be established. So when I draw this sequence between this ISC and VOC, I am able to derive a neat type of a graph. Sorry, I draw it in a PowerPoint presentation in an animation, so the shape of a wave sometimes could be slightly better. So please take a note of it. You can look into the diagrams exactly what is mentioned in the nameplate of the manufacturer or in the standards. But the theory is very simple. We are truly able to understand what is the maximum power point, where I'm able to estimate the maximum power current and I'm able to estimate the maximum power voltage. So the difference between the rated value at ISC and the maximum power point that is produced during the testing, what is the difference between these two, and what is a maximum power? Is it matching to the nameplate details of the panel is very critical. And understanding this, please note during the different conditions, you could have a different interpretation of the curves. Now, if the curve, for example, as you see from the diagram, let's start from 2. If you have a lower current, yeah, the what does it mean? Again, I've taken this points from the standards. You will also find this from the Indian standard as well, exactly the same parameters. The low current means, for example, the PV modules are degraded. There is a strip shade, which is primarily what I'm not able to have the maximum current that is established during this measurements. The irradiance measurement problem or irradiance is too slow. If that is happening, my current is going to be reduced. Now let's get into the voltage. If what is the voltage problem could be, for example, a conducted or a shorted bypass diodes or a PID issues could be there when you see that there is a low voltage on the voltage sides. So the measurements causes a PV cell temperature difference to the different value. Now let's get into the curve of 4 and 5, where there is a rounded knee, the manifestation of the aging process. This is important. You will usually find this manifestation in older power plants, typically in older power plants. And test number 5 is a shallower slope or a vertical leg. So if you find the test number 4 and 5, you will find there could be, for example, a wiring damage, or increased module series resistance. So this 4 and 5 could be sometimes related to the really about the aging performance of the panel itself. Then let's come to the step number 1, which is array or a module which is partially shaded or a damaged PV cell itself. So the shape of a curve is very important. And how do I interpret the shape of a curve? If you get, for example, this is also quite important. Let's say if I get a less value, could be even on my maximum power point. Please check the conditions again. Try to do the reconditions. Maybe try to do a repeatability of when you have clear conditions again before you interpret and conclude there is a problem, because during such kind of measurements, some of the atmospheric conditions plays a very critical role. So, as we know, the increased irradiance, as this being a semiconductor, when I increase the irradiance, the current production is significantly increasing, but it is also very important to note it is increasing equally, which means the manufacturers usually say this is a good semiconductor, it is increasing gradually. The maximum power points on each and every irradiance, as you see, is changing also. And the increase in cell temperature decreases voltage, slightly increases. What I mean by this is, if you have a temperature increase, for example, all the SCC conditions will be at a 25 degree. Let's say you are having an increased temperature at a 50 degree, you should be expecting a lower power compared so here the voltage is changing so drastically, but the current is not changing drastically. Some of the examples from some of the manufacturers, as you see from the data sheet of these manufacturers, you will see mostly that is, though I'm not associated with any of them, just for us to understand how the characteristics are working in different manufacturers. I've checked in almost all the manufacturers. I've given only some examples for us to understand. They show there is a importance on drastically increasing the current with increasing the radiance. It is evenly increased, and you can also see there is almost an evenly increased situation when you compare it with the temperature. So in our equipment, when you make such kind of measurements, you are able to plot the difference between the STC condition, because as I told you, we are able to feed in the details of the manufacturers who are manufacturing, I mean, the details of the panel itself, and I'm able to plot out the IV curve measurements. Then this is actually a very common test, a thermography test, which is used in the panel measurements. But what is written in the standards are quite interesting about this IR camera. So some of the nuances are clearly mentioned. How to do, what are the important points to look into for an IR camera used in a solar farm. There are the choice of a camera, how far you're going to make a measurements, you're going to deploy a drone, you're going to hand carry. This is the choice of the customer regarding the size of or the volume of the installation that you handle out. But if you look into it, this specification is your choice, but IR image is an IR image. So let's get into the topic of IR image. The purpose is to detect an unusual temperature variation in operating a PV module in the field. Such temperature variations may indicate a problem within the module or an array, such as reverse biases, bypass diode failure, solder bond failure, poor connections, and other conditions. So now if you look into it more, the irradiance in the plane of an array should be greater than 400 watts per meter square. This is very important in all our analysis. I will say at least if it is 400 or 700, let's try to take some conclusions when we make a measurements. The sky condition should be stable. Ideally, irradiance should be relatively constant, more than 600 watt in the plane of an array, to ensure that there will be a sufficient current to cause discernible temperature differences. So only when the irradiance is higher, my current is increasing, and I'm able to plot some sufficient changes on the temperature. Viewing the array from the rear, that is from the rear side of the panel, will minimize the interference of light reflected from the module glasses. All the thermographers knows that you have to be careful about the reflection, but viewing from the front usually provides the discernible images due to the thermal conductivity of the glass. IR modules also helps in identifying what are we going to look into it as if the temperature is uniformly disturbed or if there is any junction increased temperature. For example, you see in the it is normal for a PV module to see a temperature gradient at the edges, labels, periphery, and supports. It's normal. The hotspot elsewhere in a module indicates an electrical problem, possibly a series resistance, a shunt resistance, or a cell mismatch. In any case, investigate the performance of all modules that show significantly hotspots. And IR test results on bypass diodes, for example, are hot, and check the array to look into the obvious reason. So once when you see the bypass diodes that is hot, or once when you see the cable connection that is hot, then you go and do the corrective action. That is exactly what is mentioned out in the standard. So there is a procedural, some of the reference method that is mentioned for us to look into the scenario where is the hot temperature, then go and take the corrective actions. So for example, if you identify when a bypass diode, then you take a decision accordingly. If you find it in a cable connection, then take a decisions accordingly. So this is important for us to understand. Then the blocking diode, but usually blocking diode tests are not in the operational. It is usually done to understand the diode conditions. Usually done before the energizing of the panels. Let's say usually in the construction places. And then again, the shade evaluation. This is important for rooftop installations, not necessarily on the farms. Usually, I find the shades are not a problem in the farm installations, but majorly, as you see here, if I have a shade, I'm not going to have a irradiance, which means this part of the panel is not going to produce the necessary power. In the last webinar, I think I have been told to show the reporting format. This is a reporting format. The annexure A and the annexure C. You will find also this annexures in the Indian standard. So as you can see from here, my client installation address, test dates, contractor's name. I did the testing as per 60364, and then I'm going for the PVRA inspection. And for a PVRA inspection, all the tests that I mentioned, VOC, ISC, the capacity, string test, polarity, earth continuity. So this is the sequence of tests that I will be making out in my reports. This is a template that is given in the standard itself for us to look into it. Now I'll quickly summarize the products. It's just 2 slides for me to, because I've shown many of the tests. So it's just for me to summarize how we theoretically or come into the life of the equipment itself. So what you see on the screen here is a model called MPI 540 PV. This is specifically kept out for the AC part of installations. And all the 3 products that you see are for the DC part of installations. The IRM one, which is the irradiance measurements. Then there is 2 more modules, PVM 1020 and PVM 1530. 1020 is for the 1000 volt 20 ampere applications, and 1530 is for a 1500 volt 30 ampere applications. There is a LoRa interface between the IRM to any of the modules. That is whether you choose a 1000 volt or a 1500 volt. So the irradiance is continuously getting transmitted from this particular device to this particular device on a continuously, not consistent, continuously this value is being transferred, and the IV curve is actually measured. So quickly to summarize, first you see the AC part. All the 10 testings that I mentioned to you can be completed in this one device. And then when you go to the DC part, you definitely need an irradiance meter. Then the choice whether you're going to make a measurement on a 1000 volt. If you decide you're going to make a measurement on a 1500 volt, that's a different device. Long summary of this device. It does everything that I mentioned as per the standard, all the testing that I mentioned as per the standards, 10 testing that I mentioned, you will be able to complete it in one single device itself. That's the whole philosophy of our measurements. For me as an electrical engineer, whether I take a measurement, same equipment into a solar farm or a EV charging or a residential building, for me it's a node, and 60364 applies for anything of a 1000 volt AC. So all the methods are applicable in wherever we make a measurements. A quick snapshot on what is possible. Yeah. So I can do IR, I can do soil resistivity, earth resistance, follow-up impedance, RCD measurements, phase rotation. So almost everything that I will be, what I mentioned to you until now about the 60364 can be completed in this one device.
Okay.
And when we talk about the DC part, we have two devices, which is for 1,000 volt. The name, the model number was decided as PVM 1530. That is, 15 is for 1,500 and a 30 is for the maximum panel current that is possible for it to do. And this is probably one of the smallest 1,000 volt meter in the market to my knowledge, which does 1,000 volt and a 20 ampere measurements. Please look into the irradiance meter proper connections. This is but we do we supply with all the necessary tools for you to make this proper connections, the orientation of the angle, calculating the cell temperature correctly. So this is all considered. This is the first testing which I mentioned to you for the AC part, which is the only test equipment which you require, that is reaching up to the source end. So the regular testing devices will not be able to complete the testing, because when you reach closer to the transformer and you're increasing a voltage, which is about 800 volt. When you make a milliohm measurements, you're expecting hundreds of kiloamps prospective short circuit current during these measurements. So there is a special testing. I'm actually proud to tell that we are one of the company globally to have such kind of devices for making a follow-up impedance up to a 900 volt measurements. Usually some of the clamp meters that is also required, and we can extend the voltage up to 3,000 volts for the clamp meters. Let me take another 2 quick minutes for the power quality. As we all know, power quality is an inevitable factor. I'd say 2 minutes because the next webinar is about power quality, which Mr. Dominic will mention after the presentation. So it's about power quality and continuous monitoring of power quality, which is very important. We've come out from a portable device to a modular construction with a built-in web server, and which is having the watchdog functions, and will be able to produce the reports in a PQD format. This is important for us to know what is given by the government utilities for the solar farm. This is TS Transco's guideline. As you can see, the guideline is talking about the measurement or the power quality assessment for a TDD. The recording and the reporting shall be as per IEEE 519, and all that is how you are going to make a measurements and how you're going to report for the solar farm. And this is applicable not only for TS, I think it is also available in most of the states right now. TAN Transco has already released the guideline, I've noticed, for Maharashtra, and I mean most of the state utilities have come out with the guidelines, and usually the guidelines falls behind the regulation that is given by CEA also. So two important points is your device is Class A and it is IEEE 519 2022 standards is important for a continuous monitoring of power quality. We have a special session only about power quality. I think that will be the next topic of our webinar. So here I will stop about power quality and we'll get into the other topics. So all that I mentioned until right now, if you would like to have a quick view on how do I make a practical test, we prepared some YouTube videos also. Please feel free to watch these videos. We are showing how to make a connection, what is the resistance, what are the precautions you need to take. So it is a, let's say, a live demonstration that is available in the YouTube. So please, if you're interested, kindly have a look into it. Now I'll make a 2 minute summary of my company. So totally, we as a company, we are operating in testing equipments, automation, calibration, and LV current transformers. So this is the overall portfolio in terms of testing equipment, starting from the transmission up to the end user to the industrial places. We have about 200 plus SKUs in our portfolios. We also work on the automation side, where we supply the RTUs and the distribution light automation systems. The calibration that is required for the meters, and also from the special CTs, where we have recently a joint venture association for a German corporation. So we have jointly associated with this CT actually. So on a summary, if you have any questions, my email is sham@sonal.com. If someone would like to have a copy of this presentation, please send an email to sales@sonal.in. Our team will get back to you and share the slides in a PDF format. Please write an email to them. whoever is interested. So that's all about it. So thank you so much. Actually, it took a bit more time, but this is a vast topic. So I hope this session was useful, and I'm free to take the questions.
Yeah. Thank you, Sham. We have now almost 1.5 hours
Yeah,
on this. I wish we could have divided this whole session into two parts.
yeah, yeah.
And so much of interest been shown by the audience. So much
Mm-hmm.
of questions. Chat box is full
Okay,
of questions. Now Q&A box,
okay,
we have almost 26. I'm sure it will go 30. We should have split this into two because here so much of
okay,
informative. Each
okay,
slide has wealth of information,
okay.
and the various product of Sonal could have been much more elaborated. I'm
Mm-hmm.
sure. I know we need to run this again. Maybe after second series, third series, we have to run this.
I
Uh,
apologize
mm,
for taking a bit more time.
It's not sorry.
But this
Look,
is
everybody
really
interested,
difficult.
but our attention span is around 1 hour,
Yeah.
and still look at the questions. So anyway, I leave it to you because
Mm-hmm.
there are a lot of people raising their hand to want to interact with you. I think we have one gentleman I'll just take because Vijay
Okay.
Kumaran, he's been. I'm going to allow sir because from the beginning he's been asking to
Please,
others to
please, please,
talk. I
please,
am
please.
allowing to talk. Vijay Kumaran, you can talk to Shyam, you can unmute your mic and please talk to Shyam directly.
Hello.
Vijay Kumaran, please take. If he's not, online, I'm going to unmute. Okay. Now there are questions. 26. You click that question answer. Shyam, you can take one by
Mm-hmm.
one. Whatever relevant to today's topic, you can take it up. Vijay
Okay.
Kumaran, you want to talk?
Yes,
No.
Mr. Vijay Kumar, and we can see your hands being raised and you're also unmuted. You
Uh,
can speak.
okay, take up questions. Sundaram, you want to talk? Please, I'm allowing to talk.
Hello, sir. Could you hear me?
Yes, please,
Yeah,
sir.
okay.
You're
Go ahead,
fine.
Sundaram. Yeah,
Great, sir.
quick.
Very
Can you introduce from where you are, and it'll be nice to
excellent,
understand.
nice, informative from the fundamental. Quickly, my question is, sir, we have planted near Trichy. Some of the issues we faced in last 3 4 months, we gone for 1:1.3. That is DC higher side 1.35. We have a good P inverters, but 250 kilowatt good P inverters. Frequently, it's get failing. Out of nearly 40 inverters, 26 inverters failed. And as SAR said, we could do some thermography and we have to find out the temperature, everything. But from the side, they told that it is because of the reason is in DC bus, the voltage is get raised. So now they're going for replacing 250 to 350 kilowatt. How do you suggest, sir, advice?
Mhm. So when you say there is an inverter failure, you're saying about the inverter failures.
Yes, sir. Inverter getting failure very often, sir.
Okay, sir. Since it is in Trichy, sir, maybe we can, it's not far away for us. Maybe we can try to come and make a visit to your site and understand it in deeply.
It's in Trichy to Perambalur highway, sir.
Okay, sir. For me, it is just, I will say, 3 4 hours of drive.
Okay.
Is it possible for us to come and visit the site to understand? Because you say for 26 out of 40 has failed means maybe we need to, what I mentioned until this moment is for the verification. But here I see that, sir, at least there's most of a failure. Will it be okay for you to accept if we make a visit to your site, sir?
Yes, sir, definitely, sir. How to contact, sir? Can I get your contact number?
Yeah, yeah, yeah. I will.
Sundaram, we have
We
your
will text
contact
you, sir.
details. We have your
Yes,
contact
sir.
details. So we'll get back to you because we have many questions
Sure.
and all that.
We will
So
definitely get
Sonal
back to you,
team
Mr.
will
Sundaram.
Yeah, Sonal team will contact you because we have your detail. So we'll pick up from
Sorry,
the registered mobile. Or
thank you, sir. Right,
it is
sir.
good that we contact you. We'll take it forward. Thank you, Sundaram. I will take
Thank you, sir.
there's one more
Thank you.
Vijay Kumaran last request. If you want to join, you can ask question. Vijay Kumaran. Okay, Raju Antati, you want to speak? Raju? Mr.
Hello.
Raju? Yeah, go
Yes.
ahead,
Can
Mr.
I
Raju.
audible?
Audible,
Yeah.
audible, sir, please.
Yes. Actually, we have installed the solar system on the residential apartment.
Mm-hmm.
But now, can you get the solar power inverter? We are taking the this one EB supply for reference voltage.
Okay.
Can you get take the reference voltage from the DG set so that we can efficiently use the solar system in case
Can
of
you
failure of in case
can
of
you please ask
failure
the question again, sir? Can you please repeat the
in
question
case of
again?
failure of EB supply,
Okay.
we can't get the inverter output.
Yeah. But depends what type of system you're using, na?
Net meter connected to grid.
Correct. But there are different type of system, na, sir. Some of the hybrid systems are allowing you to do even if there is no electrical, I mean, even if your EB is off.
Actually, I have connected to grid. In case
Mm-hmm.
by providing the reverse power protection, can I use
Mm-hmm.
for the in case of failure of EB supply? Can I use
Mm-hmm.
this one for DG taking the DG reference and using the? Can I use the solar power for other
From
purpose?
my point of view, from my understanding, it is a no. You should not do that. This is my personal opinion. Let me also refer to the circuits in the standards, and I will write this answer back to you by Monday, sir. From
No,
my
they will
point of view,
contact
I
you
will
directly.
say, yeah, I will say it is.
We will talk to you directly offline after this webinar. We will talk to you because we have so many questions to answer. Your question is understood. We'll Sonal team will get back to you and find a solution for
Because I
this.
need to check the manufacturer details, what is the rating, and if there is any prescriptions, then I will give you my answer, sir. If you could allow us to contact you back, we will contact you. Yes, Mr. Dominic, next question, please.
Yeah, Raghavan Thomas, you want to talk? Let the question be very crisp. Raghavan Thomas, Rajesh Gumadi, you want to talk? Please go ahead.
Can I take the questions from the Q&A box, Dominic,
Yeah,
sir?
please. Yeah, please go ahead.
Is this audible? Hello.
Yeah, audible, sir, please.
Yeah,
Oh,
Rajesh
yes,
Gumadi.
you have told about several tests from DC side and AC side.
Yes.
These are required for all types of solar plants or for industrial plants ranging from 10 megawatt to 50 megawatt or something
No,
else.
sir, it is for all solar plants, sir. If you have
Also,
all solar plants, sir, there is it's not a differentiation between the ratings, but as we
okay.
know, the standard is not applicable for if we will say, for example, a residential premises. Yeah, even in my
Hmm.
house, I would require a fault protection, but is the standard
Transformers are
mandating any?
very
Hello?
Sorry.
Oh, okay, sir. Okay. So, is the standard mandating or it is a push from the regulatory authority? Possibly no. So, for your question, all solar farms, sir, all solar installations.
Are this all required for only for running installation time or for running also?
For
For
running also, sir.
running plant? For?
Definitely, at the time of installation, it is very important to check all the parameters from the AC side and the DC side. And for a routine maintenance, I will recommend at least once a year. Maybe worst case scenario, 2 years. Every panel,
All that, is there any specific test or all the tests needs to be
all the
done for
tests, sir.
the routine?
All the
Okay,
tests.
okay, right.
Why I say this slightly exception to the second year is, for example, sir, if you will take some high dusty environments where there is a lot of, for example, in the Middle East conditions, the panel is completely covered in the dust. So the amount of power production is comparatively low. So the main agenda for the customer is always to clean the panel. In some instances in India, for example, we see the ambient temperature, or it is a very highly polluted environment. So there are a lot of environmental factors behind this decision from the customer. You can also refer to the guideline or the recommendation from the local state utility. For example, I showed a screenshot of TS Transco. This TS Transco guideline is for the entire solar installation. I showed only the screenshot of power quality. So there will be a guideline from the local utility as well. How often they wanted to make the measurements. But for power quality, they are insisting actually every year.
Okay, Sham, let's go to Raghav if you are there, or Abbas. I don't
Yeah.
know who's, yeah,
So
please go ahead.
this is Raghavan Thomas.
Please, sir.
This is regarding this. We have a residential project, 30 kilowatt capacity.
Okay, sir.
We are planning to do the project actually.
Okay, sir.
I want to your suggestion. And other people are also facing inverter problems. The domestic
Yes, sir.
inverters, manufacturing inverters is not up to the standard, substandard. But I feel to better which manufacturing best of our inverter to install.
So,
As you were
sorry,
suggesting.
sir. I will not be in a position to comment the manufacturer name in the public presentations. But regarding your questions related to 30-watt capacity, first point, if we understand this from the verification and all this scenario, sir, if there is a fire accident in a solar farm, we have only a commercial loss. And if we have a fire accident in a residential premises, it is much more dangerous because we have people living around. So it is very important for us to have this installation safe and soundly completed. Regarding the inverter issues, 100% I agree with you. The moment you finish this AC part and the DC part of verification, the only part which you are left out to do is your inverters. And now inverters, there are, as you rightly pointed out, there are different classes of inverter manufacturers, and there is lot of power quality issues. There are n number of papers presented about power quality and power quality related concerns in a solar farm. One of the main reasons always being the inverters and how it reaches and affects up to the transformer. So I can't make a recommendation of the inverter, sir, but I will be more than happy to suggest or help you out with the complete installations and the measurements when you do go for such kind of installations. Between which city are you planning to do this installation, sir?
No, he is from Tamil Nadu, he said.
Okay.
I removed the permission to talk.
Acha, acha,
We'll
okay, okay.
we'll directly get in touch with them directly.
Yeah.
So, Abbas,
Okay,
you want to talk, or shall we go with question answer, which is lined up? Abbas? Okay, take up the question, Sham, because
Okay, let
already
me
now
take
we
up
are
some of the questions because I
yeah,
apologize
please.
again that I have
Yeah,
taken a bit more time, so I need to finish off these
yeah,
questions. I have given my email
okay,
address in
please.
the presentation, so please reach out my email. So some important questions. TT systems and TN systems, what is the difference for best as per the technical specs? Again, we will not say what is we will not wanted to say what is the best from our company point of view. Sorry, is my screen still shared to you? Can you see my screen? Dominic, sir?
Yeah, Shyam. We can see your
We
screen.
can see, okay. So this is the diagram. I have hidden it, but if you see by 6311-2, which talks about the which talks about the earthing of a PV array. So whether it is what is the type of a construction on an earthing, because in the previous presentation some of the customers did mention what is happening is we have a separate earthing for AC, DC, transformer, lightning protection. So we end up having multiple earth pits. So that is definitely not accepted. The right earthing conditions is mentioned in the standard of 6311-2. But even in the beginning of my presentation, the first slide I've shown the same diagram, but in a slightly modified, pictorial way. This is the right earthing practices. Then the next question is, what is the resistance of single earth pit and a group of earth pit? I will say a single earth pit and a group of earth pit is not very important, sir. It is very important to understand, do you have a coordination between the protective devices? Why? Let's imagine the same diagram. Let's imagine the same diagram, what you see on the screen here. You see only one earth pit that is connected into this ground, and there is a small dot. That's where the connection is. Now, when you make a measurement of earth pit possibility, you disconnect the earth pit and then you make an earth pit resistance measurement. Let's say you have 1 ohm or a 5 ohm. It doesn't matter. If you do not have a continuity established, and we do not know what is the ohmic value of that continuity. If the continuity is not proper, and let's say you have a bad continuity or a high resistance in that particular area, let's say you have a 10 ohm continuity resistance. Now, if you maintain an earth pit value of 1 ohm, the total resistance becomes 11 ohm. So it is important to understand the earth pit. I completely agree with you, but much more important is to understand if you have a right coordination between your protective earth devices, protective devices. While inspecting an electrical system, how can we identify whether the earthing is TT, TN, IT, or any other type? Sir, generally, what is this types of installations is also mentioned in the standards. You will find it in all the Indian standards, 732, in all the references. But what is generally is T is terra, which is grounded to earth. TT means you will find the source is earth, and there is also a lot of earth pits that I mentioned. The load are also connected to individual earth pits. In TN, there are two types of TN systems. There are TNS system and TNCS system. TNS system, as I showed in one of the presentation, that is the most ideal, or for the for-loop impedance measurement method. You have a separate PE conductor and a separate neutral conductor, that is TNS system. IT system is the transformer is, as you see, T is terra, which is earth. IT means the transformer that is a source and is not grounded. So it is an isolated grounding system. Is there any certification available for performing earth for loop impedance? Yes, NFE is doing that certification. You can contact Mr. Dominic or anyone from NFE, or you can even contact us also. We will help you to loop with the NFE association. They are giving the certifications for loop impedance measurements and techniques. And they actually give it in 3 levels, level 1, 2, and 3. And when you reach at the highest level, you are making a measurements on the source end. What I mean by that is I even showed it in one of the presentation slides, doing a loop impedance measurements on the source end. So that is your level 3 certification, as you see on the screen. Yeah, that's your level 3 certifications. NFE in India is giving this certification. Next question is, what is the maximum capacity? It's purely your decision. Is there any lifetime you said? So the lifetime you said is 17 years. After that, is any recycling procedures? So I don't say the lifetime is 17 or 25. Usually that is given as a manufacturer warranty itself in some of the panel manufacturers. They say this is the life of my panel. I'm giving, there are certain conditions also. I'm giving warranty for the panel of this many days. I'm giving the total warranty for the panel is this many number of years, etc., etc. Yeah. Roughly, understanding anyone who is involved in PV or a PV installation part, they are talking about 20 or a 25 years lifetime, in which the return of investment can be taken out in 8 years by doing the simple mathematical calculation of the cost of installation. But if you really want to run the panel after 7 or 8 years only, you are actually having a return of investments. When this is a DC system and the maintenance is not proper, it is, I don't know if it is really possible to have a system to run for 20-25 years if the maintenance is not appropriate. That is exactly what I wanted to say. Compared to other instruments, Sonal have any special features? Definitely, yeah, I can answer this question in this particular way. We focus on the safety. we focus on the entire safe operations of the engineer while making these measurements. This is very, very critical, and this is in our DNA of our measurements. Second most important, when you make a measurements, this is also something which we are working very closely on. Your engineers might not understand every breaker rating. It is okay, it is not okay. So what we always try to feed in is we try to feed in the database of all these breakers into our equipments itself, so that your engineers is only comparing with the database of the breakers and whether the fault loop impedance is safe or not safe. This is not usually available in the companies. Generally, I have not seen the company who are able to analyze in the equipment itself from the database of the equipments, and the engineer is seeing a screen pass or fail within the equipment itself. Most of the panel manufacturer ensuring performance warranty for 25 years. This is very long period. How can we expect manufacturer existence? It's purely about the manufacturers. There is one question about illuminance test. Illuminance test is about the light intensity of measurements. Can you share once again DC insulation test? Yes, it is the same insulation resistance measurements. The theory is same. I'm making a measurement on a DC insulation, but please understand, when you're making a measurement on a DC panel, you are not able to disconnect it. Yeah, like an AC system, because a panel will produce the power if you're doing it on the sunlight. So here you have to be very safe while making the connections of your equipment to that MC4 connections and start doing the insulation resistance. And I'm already 47 minutes more than my appropriate time. So I have to stop the questions. Sorry, Mr. Dominic, I think I exceeded the time frame so much, and I'm not in a position to contact the questions here. I will share the screen once again about my email, and for my email, this is the questions. We will try to answer these questions maybe by email to all of you. But if you need a copy of this presentation, please send an email to sales@zonal.in. We will contact you back. So, Mr. Dominic, maybe we can wind up the session. Is it okay? I really try
Yeah,
to.
Sam. Hi. Yeah, Sam. We can wind up right now.
Yeah.
Yeah. Thank you so much for your time. It was a very interesting topic. I think we have a very good audience as well.
Yeah.
We look forward to your next webinar, which is happening on August 23rd. For the audience, I have shared the link on the chat. So see you all again on August 23rd. Thank you, Shyam.
Thank you. Thank you. Take care. Thank you so
Thank you.
much for this association. Thank you.